Alright, so I think I'm gonna like try and just like make some little videos of like what I'm fucking around with, because I just like basically sit down in the evenings and like write code for random shit that I'm interested in. And so today, what I ended up writing was I'm starting to work on kind of an experimental database that's written in Julia, and it's kind of intended to be like um, natural language first. So, the intention is that it replicates some of the functionality of a vector database, because you want to be able to search across, documents and embeddings and things like that. You also want to have some kind of a component of a graph database, because you want to be able to model semantic relationships between documents, or vertices and stuff like that. So I'm just kind of like messing around with it for now. There's been some mixed stuff, I've been playing around with, but today I've decided that I'm just gonna like build this thing for a specific applied purpose, and then like kind of let the database arise next to it while I'm working on this project. And so the thing that I did was I got a hold of the ISO specification for the GQL query language. And the GQL query language is weird because it's one of the first new ISO standardized database languages since SQL, which was like way back in the day. So GQL is very new. And if you're familiar with graph database syntax, or graph database query languages, it very much resembles Cypher, right? And so Cypher, I'll show you over here just like super quick. It's like basically match and let's see, I don't know, Alice, person named Alice knows Bob, person whatever, right? So this gets you like you can connect a vertex labeled by person through a relationship, which is knows here, and then some person that has a name Bob, and then you can return just Bob's name, right? Which in this case would just give us Bob. So anyway, that's kind of what GQL looks like. But the problem is that in Julia this like doesn't exist, right? There's not actually, very few people actually have GQL parsers. They kind of don't exist because like the ISO standardization wasn't released until I think mid-April. So a lot of people have been know that this is in the works, and it's like close to Cypher. So if you can parse Cypher, it's like relatively close. So what I'm building right now is I took the PDF document, and I'll show you kind of what it looks like. This is like it's a very dry document. I won't show you too much for copyright purposes, but it's just like super dry. I don't think I've ever, I'm an academic. I have like a finance PhD, and I was like looking through this, and I was like, oh, holy shit. Y'all are boring as hell. I don't want to read this, right? Like, oh, fuck. Come on. So dense, right? So I got tired of trying to read it, and so what I did was I took Nougat, and Nougat here is a Facebook product that takes PDFs and converts them to text, or converts them to Markdown basically, and it'll also support like LaTeX and things like that. So it'll extract math as well. And I have this nifty little script here. All it does is it goes through every file or every page in the PDF. It converts it to an image basically, and then you pass it to Nougat, and then Nougat will generate a transcription and put it in this output text folder here. So we get a bunch of Markdown documents now. So this is the thing that we pulled out from Nougat. So there's a bunch of Markdown documents. And then what I did is I want to start doing like, if I want to start like building a GQL query language for a database, I might as well start by making a database that contains all of the documents and embeddings that represent the query language. So the idea here is that like in principle, I can just kind of like build the database with the database, right? So you ask the database, oh, hey, like, how do I actually build this match statement? And then you can say, oh, okay, then the database can respond, and then you can build it in the database, and then you can keep growing. So it's starting out as a repository for all of the instructions to build the database. So I'll show you a little bit about kind of what this stuff does. It's currently entitled Gigabrain.jl. There's some let's see here. Yeah, so I like doing little ASCII stuff up here, but there's a few. This stuff that's in the main module is not very good. It's kind of, I think I'm moving on. This stuff is all kind of intended for like bitwise storage. I can talk about that later. But most of the work I did here was in like building kind of the vector side of the graph database. And so this stuff is super dumb. Like there's no storage engine. It just dumps shit into a folder, right? So it's like, it's a database in the same way that like, your hard drive is a database. Like you just use the operating system to find stuff. So it's really dumb. But I'll walk you through all the bits and pieces here just because I like doing that and like talking about it is helpful. So we specify like a few locations of different things. This is like stuff where the database is going to put files. So we store vectors and thoughts separately. So vectors are like, I have a binary format that is like kind of like hand rolled to dispatch, and I'll get to that in a second. And then thoughts are like specific documents. Like this can be any kind of like text content, but eventually it will include images and video and stuff like that. The abstract Gigabrain schema is a super type that represents a combination of prompting tools components. Right, so prompting tools is this fantastic library in Julia that Jan Simmel spent a lot of time on. And basically you give it a schema, and a schema here can be like Olama if you want to do stuff locally. This can be OpenAI. This can be Grok if you want anything like that. It supports like Together and Fireworks and all this other stuff. So you can dispatch to any particular backend you want, and prompting tools will just handle sending the API requests and formatting and everything. And then you give it the specific model, because I wanted to be able to like create a callable struct, which is a voice where you basically call this voice with a prompt, and it will call AI generate to get, basically to respond using that model to whatever the code is. So the syntax for that basically looks like you would call voice, hello, partner. And actually I have an example of this over here, so I might as well just show you this. Here, let's make a cheat voice here. So cheat voice uses prompting tools Olama schema. This is basically just me. This is running on my laptop. And then I'm using Phi3 because Phi3 is super cheap. It's it's like 2.7 gigs, so I can load it into the tiny graphics card that's in this laptop. So I can do cheap voice. Hey buddy, what's that? And so we'll see this stuff kind of come in here. It says, oh, hey, I'm an AI, I don't have feelings, blah, 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 right? The cool thing I wanted to do here was I wanted this to be a callable struct. Like I wanted this to feel like a functional composition so that eventually you can pipe a series of function calls together. So there's some other stuff in a separate project called Colang that I'm working on that I might talk about later when I'm working, like sit down and have more time for it. But just kind of going back to this, I also have an embedding schema. This handles like how you want to treat embeddings within your system. This is like fairly boring, but this also works with promptingtools.jl. Excellent fucking package. Cannot recommend it more highly. But AI embed will just like create some embedding vector. In this case, I'm using the Nomic embeddings, which are actually pretty good. They're like relatively cheap, and you can run them on your laptop. So I can embed this entire set of documents in like, I don't know, 30 or 40 seconds on my laptop. Then I have here is an index, and so an index is a unique name, so it's like a namespace. So in this case, I'm using GSQL. Is that what it's called? I don't know, it should be called GQL, but I call it GSQL. And so that's a way of containing certain documents that you think are related to one another. So this should resemble, if you've ever used Pinecone, this kind of resembles Pinecone. Dimensions here is basically going to be how big the embedding vector is. So this is 768 in the case of Nomic. And then you can pass in your schema, your embedding schema, so that it can use it anytime you call the embedding stuff. So skip through some of that stuff. A thought here is any particular document, so it's just its hash, which is how I'm storing everything currently. There's going to be a way fucking better way to store things than hash right now, but hash is super simple. So then you store the text, so this is the content of the document, and then the associated embedding vector. And here's a couple of constructor methods that like basically try to load the thought. If it doesn't, try to load the thought if it's on disk, creates the thought if it doesn't exist by like embedding it and getting a hash and all that stuff. Then there's some convenience functions. This thing here is called memory, and a memory is a series of loaded documents, right? So the index describes where and what the documents are, but the abstract memory contains the exact documents, and so you can kind of eventually you'll be able to do conditioning on like what memory flows to which processes and things like that. But this one's super basic. It just is like a bucket of thoughts. Then you can save your index, save a thought to your index. That's kind of boring. It just kind of serializes it. Load will go here and it'll look for everything inside of your vector and thought path, and then zip them up into documents and then put them into. This one loads a thought by its hash. So if you have the hash, you can load it in as a thought because it can just like go look at the files. Blah blah blah. Build index here is how you actually iterate through thoughts to construct them. All right, let me skip here. I know I'm being very confusing. Build memory. Then this is all like standard RAG stuff, so I won't go into that too much. So let's just go look at the example. Pick our embedding schemas. Okay, so here we're going to set our index, right? This describes where everything is and how big we should expect it to be. So here I'm just giving it the name GSQL 768, and then I'm going to give it the embedding schema here, which contains which model or where we're going to run it. So my laptop, and then what we're going to do with it, Nomic embedded text. Okay. Then we're going to build the index. So we're going to load we're going to get a list of all the files we want to load. In this case, it's everything in output text, which is all these like random markdown documents that are impossible to read. And then we're going to inject it into the database. And so build memory goes through every single one of those documents. It gets the embeddings for the entire document, but it also does auto chunking based on sentences. So if you just want to extract based on sentences, you can do that as well. There's some debate, like this is not the best way to do chunking. There's like a lot of people who think really intelligently about how to do chunking. I don't do any of that shit. I just dump it in the big bucket and then put it in the context window. We'll deal with it later. Okay, so this is a method to do simple search, right? So what you do is you give it the index. So where should you be looking? Memory, what documents do you have to look at? What is your query? And then how many documents should you retrieve? So let's run this. And then we can look through a few of the responses here. So a GQL client is a processor capable of establishing a connection to a GQL server on behalf of a GQL agent that is authenticated to represent a principal. A GQL client is perceived with a GQL, this is the kind of incredibly dense language that's in all these documents that I want to get rid of. But this is the raw document this is like the highest cosine similarity document that we got out of it. So this is like stuff that eventually we would want to put into a context window. So this is super simple semantic search, like nothing complicated. It's just cosine similarity between vectors. Go into that later. Then there's voice construction, which I went over briefly. So this one is a cheap voice. You'll notice this one here actually uses Grok on the back end, right? So Grok is super fast, right? It serves like Llama and Mixtral and kind of the other open source models, but it does so really, really fast. So in this case, I'm asking it for the Llama 3 70 billion model. And then I have this preparation voice, which is cheap. It's the 8 billion model, but it's also on Grok. So this is kind of an experimental thing. I don't think it works super well yet, but I'm still parsing it out. I'm going to zoom out. So I have this planning question where I want to say, I have a high level question that I want you to answer. So like the question, I want to know, what's an example of a valid GQL query? And there's so much garbage in, and I do say garbage, there's a lot of like stuff inside of the query specification that's like really complicated. And so the idea here is basically to say, what are all of the documents you need to retrieve that you might want to pass to like a higher level agent who can kind of like process and summarize things that it might need to know to get to understand. So I'm asking it for, what 5 questions would you ask to try and understand how to provide a valid GQL query? Please provide in a numbered list. You should be doing this with structure generation, but the structure generation stuff in prompting tools is still coming along. Jan and I are still working on it. Okay, so we're going to do the preparation step here. Okay, and so here's the answer we got is, what's the basic syntax? How do you specify a property? What is the role of the keyword match? How do you specify multiple conditions? And what are some common error handling techniques in GQL queries? Right. So these are like a few questions that you might want to ask. So because I have them in numbers, I can kind of specify this regular expression here to extract lines that start with number digits, like that. And then I can filter to get just a series of numbered questions that I could ask other models to go interrogate the database to understand. So I'm going to create a buffer, and then I'm just going to stick stuff in the buffer as I go along. This is like kind of good practice if you have like if you're appending a lot of strings together. And what this loop is going to do is we're going to say like, please ask the index, the memory, this question, and this question is going to be each one of these in turn. 1, 2, 3, so on and so forth. And then we're going to use the preparation voice to do so. And then we're just going to stick some answer stuff. You know, this is the question that was asked, this is the answer that was asked, and then stick it all inside of the buffer, like this. And so it'll take a hot second here. And then once we're done, we can kind of extract the whole thing here, and we'll print out the answer. So this takes a little bit of time just because we're doing querying, stuff like this. Okay, great. So here's, for example, some of the answers we got. So the first query is, what's the role of the match keyword in GQL query? Right, so this is basically this like select, essentially. It's like the like standard. You should probably have it. I think you need this in all your queries. Again, I don't read this fucking giant document, so I don't know if that's true. Maybe you could have to start with something else. Basically says, according to the provided text, keyword match is used to specify a graph pattern. And a lot of the stuff inside of the GQL specification uses this like bracket syntax here. And so I need to find a way to like maybe contextualize that stuff better, or like provide additional documents that have that map these to their definitions. So maybe that helps a little bit. How do you specify multiple conditions for a GQL query, etc. So this stuff gives you like an example of how you might want to do that. How do you do common error handling, blah, 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 right? So now we have like a list of responses that we can ask. Can you give me an example of a GQL query? Use this series of questions and answers. Response. Okay, and then let's see. So this is also going to do a database lookup. So it'll embed this entire query, and then it'll also it'll use both the context that is provided from the database as well as the context of whatever's in the prompt. So I don't know how well this will work. I'm just kind of fucking around. So I haven't actually tried this. I wouldn't be surprised if it gave me an error for having too much shit in the context. Let's see. Cool. Well, not cool because it gave up. Okay, so no example of GQL queries provided in the text. However, I can give you a basic idea of what it might look like. Yeah, I don't know. Come on, buddy. Anyway, whatever, it didn't work, but I'm still trying. And then, for example, I can do like, how do I write a match statement, which is much simpler. And this one actually did pretty well last time. So this one actually goes in and looks at the specification. This is like inside of the specification. This one works really well. So if you're very specific, if your questions are super precise, then it does a really good job, as you might imagine. So here, like, it's kind of cool. I wonder if we can get it to do this in Julia as well. Match statements. And what is the appropriate Julia syntax for parsing such a statement? Okay, so I don't know if that'll work either. Flying by the seat of my pants here. I did this in like, I don't know, like an hour or two, so I'm like, we'll see how well any of this shit works. Kaboom. Alright. What a delightfully complex set of specifications. You're goddamn right, robot. That's why we got you here, buddy. We'll figure it out together. Okay. So, I don't know what the fuck it thinks. This is not good Julia. I don't actually know. I'm not familiar with grammar. Julia parser. Is that a thing? Let me look that up. Hold on. Julia parser. .jl. Okay. No, it doesn't seem to be a thing, so we'll have to figure out what the hell that means. And then, yeah. So, anyway, this is about what I got. I just wanted to, like, make a video because, like, I don't know, that's kind of fun. So, some, like, additional things that need to happen here is, like, I need to start modeling relationships in here and kind of handling edges. I'm actually pretty happy with, like, the real basic data storage format here. There's, like, a decent enough abstraction layer that, in principle, you can just swap it out with, like, a more sane way of storing data, right? So here, in the I/O thing, every time we do a vector, I have just like a standard serialization format. I have a leading byte. The leading byte tells you what type of floating point it is. So here we support floating point 64, 32, and 16. So it looks at the first byte, and then it says, okay, I know that this is going to be a 64-bit floating point number. It'll then read the remaining bytes and then convert them into whatever the leading byte indicates, and then it'll return a static vector. So this is just how it works. This could be like moved into like a matrix storage format. This could be like put in like Parquet or like something else that's like a more sane form of a storage engine, but that stuff kind of evolves, and storage engines are definitely not my forte. But so the edges and stuff need to get figured out, and how to start adding like labels and properties and things like that you might normally expect from graph databases. And then like maybe a super basic query parser. Like I should be able to handle this. This is like probably a hello world that I might be able to target. And then like handling traversal and like context for language models. And then at some point I would also like to be able to revisit a lot of how you handle functional compositions of language models, of voices here. And so I'll fuck around with that more later. But anyway, I don't know why you watched this, and I don't know why I recorded it. I was just like sitting here and I was like, I'm like kind of proud of this like weird goofy rag thing I built for trying to build a database that I'm actively building. Like building a database that stores the information to explain that database's query language. and then kind of like letting them evolve together. And so I'm like hoping I can just like play around with that. And yeah, if you like this, I'm sorry. And have a good day, I guess.